Hello. Composite functions. A composite function is defined as a function within a function and generally denoted using composition and composition operator or g of x or f g of x, putting a function within another function. And that can only exist if and only if the range of the inside is the subset of the domain of the outside. So in this case here, this is our inside. If the range of that g of x is a subset of the domain of f of x, then it does exist, the composition. All right, let's have a look at this example, these two functions. And it's a good idea to sketch or form a table. So let's do a table first and see how we go. And let's say this is f of x, and this is right there, domain and range, and this is my g of x. So if I give it a quick sketch of each of these, well, if I sketch this, it's going to be something similar to this. So that's going to be my something similar to that. That's my g of x. My f of x, I'm just going to call it, label it g of x. Let's use a different color. All right, now if I label the other one, which is the exponential function, it's going to be something similar to this. And that is my f of x. And my domain for f of x is going to be all real values. And my range will be, and that's my range. And my domain for g of x will be and my range will be 0 to positive infinity. And I want to find out if f g of x does exist. And we said that it only exists if and only if the range of g of x is a subset of the domain. Then how do I know that? Well, we can give a quick sketch, use a number line, and I sketch the domain of g of x, and that is from 0 included to positive infinity. And that's how it's always a good idea to have a good sketch. And that is going to be the range. So this is going to be range of g of x. All right, and if I do the same thing for the domain of f of x, it's going to be all real values. Let's see, different color maybe. Domain of f of x is out. So now you can easily see that this is part of that. So the range of g of x is a subset of the domain of f of x. So it does exist. Yeah, the composition does exist. And now we need to write down the rule. So writing down the rule. So let's actually write the rule for that. we're basically importing that. So that's going to be that. All right, so that's going to be the rule. So the next thing that we need to actually find out is if g f of x does exist. And if you go back to our drawing, so this one is -3, so we're not actually 3 to -3. So if I get my number line, and this is 3, and that is going to be, and the domain of g of x, domain g of x, yeah. And the range of f of x, the range of f of x is from 0 to infinity, to positive infinity, from 0 to positive infinity, which is only, I'm just going to use a different color. Let's actually get that color there. And from 0, which is open circle, to positive infinity. So that's going to be the range of f of x. And that's what you're going to get. So that's going to be, well, this does not exist because this is not a subset. So we need to know that this has to be a subset. The range of the inside has to be a subset. So therefore, it does not exist. Yeah, it's not defined. It's not defined. It's only defined only this section. That's it. If you were to, restrict it. All right, let's have a look at another example on this. So this has been drawn for us. So now all we need to do is we need to find out this one here. The first thing we need to do is the sketch is done. We need to form the table of values whereby the range and the domain of the two functions. And now if we do that, we actually get, let's actually get this one here. So f of x will be, and it's going to be all real values for the domain, and the range is going to be from 1 to positive infinity, whereby g of x is going to be all real values again, and this is also all real values. All right, now, if you do a quick sketch. So now we said that the domain or the range of the inside has to be a subset. So the range of g of x, so it's going to be all real values. So if I sketch that, the range of g of x, and let's use different color. And we want to find out the domain. So the domain of, well, it's going to be the same thing. Domain of f of x. So therefore, the same. So therefore, it does exist. Yeah? It does exist. If they're the same or a subset, they exist. So now, therefore, the rule will be, therefore, does exist first. And the rule will be 2x plus 1 squared plus 1. So you're basically inputting wherever you have x, you're replacing with this. The inputting there. So that's basically what the composition is. All right, and that's the end for composite functions.